Hello students, so welcome again another lecture on engineering graphics. In the series of conic section, today I am taking a problem of another method for construction of ellipse that will be known as arc of circle method. If you remember earlier, I have defined ellipse in the form of the locus of a point. If you want to define that, what we will say that ellipse can be defined as the locus of a point which moves in a plane in such a way so that the sum of its distance from the two fixed point remains same or constant. And those two fixed points are known as the focus, and that fixed distance will be equals to major axis. Earlier we have discussed about this in the chapter in the topic of introduction, and also we have justified that this definition will be a perfect definition. So today I am going to use a method that will be known as arc of circle method, in which method I am going to use this definition, or you can say this concept. I have taken a simple problem. The problem will be like this: draw the locus of a point moving in a plane in such a way so that the sum of its distance from the two fixed point is 150 mm, while the two fixed points are 100 mm apart, and also name the curve. So what they are saying that we want to draw an ellipse when the sum of the distance from the two fixed points, those the two fixed points are 100 mm apart, that will be 150 mm. So for this problem, how we are going to start? Initially, what this 150 mm, that is the sum that will be equals to major axis. So this 150 mm will be the major axis of the ellipse. So initially what I have done, I have drawn a line AB, that is the major axis of the ellipse, and that will be 150 mm. So in this problem, the major axis will be given to me, that is 150 mm, and this AB will be our major axis. After that, as they are saying that two fixed points are 100 mm apart, so the two fixed points will be on the major axis. As you know that the distance between those two fixed points will be 100 mm, and this 150 minus 100, that will be 50 mm. It means 25 from A and 25 from B, that is 50 divided by 2. That will be the focus of the curve. So this is the first focus of my ellipse, that is F1, and this will be F2. And this F1, F2 will be equals to 100 mm. That is also given in the problem. Now what we are going to do? We are going to locate different points in such a way so that the distance of the sum of that point from focus F1 and F2 remains equals to major axis. So firstly, if we want to go for the minor axis, that will be, normally we will denote that by CD. So to find out the minor axis, what we will do, we will pick half of this AB. So I am going to pick half of this AB, and from focus F1 upside and downside I am going to mark two arcs. Again from focus F2, one arc upside, one arc downside. So in this way, actually, if I draw a line from this point, as you know that major and minor are perpendicular bisector, so on this line I am going to get the minor axis, and these 2 points are our points C and D. Now if you look at this figure, in this figure this CF1 equals to half AB, this CF2 is also equals to half of AB. So CF1 plus CF2 will be equals to AB. So it means this will be one of the point on the curve. Same way, this D is also one of the point on the curve, as DF1 plus DF2 equals to AB. So directly what I got, I can easily get the minor axis. This CD is also minor axis, and we already located this CD. Now with the same method, I am going to plot some more points so I can draw an ellipse. Next, what I am going to do, from this F1 towards, if this will be the center O, F1 towards O, I will mark a point a point 1. Suppose 10 mm, I have shifted 10 mm from F1. Now I am going to use two combinations, one will be A1, second will be B1. As you know that A1 plus B1 equals to AB. So what I am going to do, I am going to use arcs with radius A1 and B1. So I am going to use two combinations, A1 and B1 as radius and center as F1 and F2. So initially I will pick this length, that will be A1. Now with F1 as center, I will mark an arc upside, another arc downside. With the same radius A1 from F2, I will mark an arc upside and an arc downside. Now next time I am going to pick this length, that is B1. I have taken this B1 length, again F1 will be center, and I will cut those earlier arcs drawn with the help of point F2. Now from F2 opposite side I will do the same. Now look at this point, suppose this point will be P1. Now distance of P1 I have taken from F1, that will be A1, and this distance of this P1 from F2 will be B1. And A1 plus B1 equals to AB, it means that is one of the point on the curve. If that is P1, then this is also P1, this is also P1, and this is also P1, and all the 4 points will be at the same distance, that is A1 plus B1 from F1 and F2. So it means these 4 points are the point of the ellipse, elliptical curve. Same way, if I can move little further, and suppose I will mark another point, that will be point 2, suppose again 10 mm from this time 1. Now I am going to use the two distances, that is A2 and B2. Again you know that A2 plus B2 equals to AB. So from this I am going to pick A2. Now again F1 will be center, one arc upside, one arc downside. With F2 one arc upside and one arc downside. Then next time B2 as radius, from F1 cut on the right side, from F2 cut on the left side. Now again we got 4 points. Again for these 4 points the equation will be same. The distance of this point P2 from F1 is A2, and the distance of point P2 from F2 will be B2, and that A2 plus B2 equals to AB. So that is also one of the point on the curve. Same way I got 4 points, 2 on the left side, 2 on the right side. Next time again what I am going to do, I will mark another point, suppose a point 3. Suppose again I have shifted 10 mm towards O. Now I am going to use these two combinations, A3 and B3. As you know that A3 plus B3 is always equals to AB. So initially I am going to pick this length A3, and from F1 as center, one arc upside, one arc downside, from F2 one arc upside and one arc downside. Now second time the length will be B3. Take the B3 from F1, cut on the right side, from F2 cut on the left side. So if that is a point P3, then now look at this point P3, its distance from F1 will be A3 and F2 will be B3, so that is one of the point on the curve. Now if you look at this figure, I have got multiple points. If I join all those points with the help of freehand or French curve, I can easily get an ellipse like this. So this is one of the quarter part of the ellipse. Same way I can move up further. Now downside. So this is the required elliptical curve. Join with the help of a smooth curve, and this method is known as arc of circle method, and this is a method in which I have located all the points by justifying that the distance of all those points on the curve, the sum of the distance of those points from the two fixed points F1 and F2 will be always equals to AB. I hope you understand the concept. Also you can easily draw a tangent and normal on this curve on any point, as I have already explained you earlier. This time there will be simplest thing will be that F1 and F2 are already given to me. So on any point on which you want to draw a tangent and normal, suppose I want to draw a tangent and normal on this point P, then join this point P with F1 and F2. And after joining that with F1 and F2, bisect this angle. So for bisecting angle, use that arc method and bisect this angle. You can easily bisect this angle and get the normal. So this line will be normal at point P, and perpendicular to this normal will be the tangent. So you can easily also do that. I hope you understand the concept. Draw this very interesting problem. Thank you very much.